Hi, in this next video on changing the base of a power, we're going to solve an equation. So we want to find the value of x here. So we've got this expression here, 4 squared times 64 to the power of x plus 7 equals 16 to the power of x plus 6. Now, we previously saw that the strategy was to make sure that we had the same base. Remember that these bigger left numbers in each power, they're known as the bases. So this is a base. This is a base, etc. And the strategy is to have the same base, because then if we have the same base, we can use laws of indices to combine stuff together, to simplify. Now, what do you notice about all of these bases, the 4, the 64, and the 16? Are they all powers of the same number? Well, yes, they are. We could say they're all powers of 2, because this is 2 squared, this is 2 to the power of 6, and this is 2 to the power of 4. But actually, to make it slightly simpler, we could pick the biggest number possible that they're all powers of. They're all powers of 4. This is 4 to the power of 1, this is 4 cubed, and this is 4 squared. So we could either write them as powers of 4 or powers of 2, but it's going to be slightly easier to write them as powers of 4 because we'll end up with smaller numbers. So let's replace these all with powers of 4. This is already a power of 4, so we leave the 4 squared as it is. But the 64, let's write that as a power of 4. Well, 64 is 4 cubed. So what we do is we replace the 64 with 4 cubed in brackets. And the reason for the brackets is because we can then raise that 4 cubed to the power of x plus 7. So we can copy that x plus 7 down, basically. And then 16, how can we write that as a power of 4? Well, it's 4 squared. So we put the 4 squared in brackets and that to the power of x plus 6. Now, this is great because we now have the same base of 4 and we can use laws of indices to simplify. So first law of indices we can use is that if you had, say, x to the power of a all to the power of b, so you raise a power to a power, you just multiply these indices together. So you do the a times the b, which is ab. So that's one law of indices. And the other one we're going to use is that when you multiply two powers together with the same base, like that, you add the indices. So it would be x to the power of a plus b. So that's what we're going to use. Let's first simplify this and this to tidy it up. So this is a power to a power here. We've got a power raised to a power. So we use this rule over here. We just multiply the indices together. So we're going to multiply the 3 and the x plus 7. Now you could write this as a bracket expansion, but let's just do 3 times the x and the 3 times the 7. It's going to be 3x plus 21, right? And then what about this last one here? We're going to multiply the x plus 6 by the 2. So it's going to be 2x plus 12. We times the x by the 2 and the 6 by the 2, and we end up with this. Now we can see that we've got a multiplication of 2 powers with the same base. So as per this rule here, we can just add these indices together. So we add the 2 and the 3x plus 21. So we're going to get 4 to the power of. So we're going to do 2 plus the 3x plus 21. Well, 2 plus 21 is 23, isn't it? So we're going to get 3x plus 23. And then that is equal to 4 to the power of 2x plus 12. At this stage, we have a power equal to a power. So basically, these indices have to be the same. If this index of 3x plus 23 was equal to the 2x plus 12, then we'd have 4 to the power of the same thing. So they would be equal, right? So at this point, we can just equate the exponents, equate the indices. So we can just write, we can equate these and just write 3x plus 23 is equal to 2x plus 12. Now we've got a linear equation where the x is on both sides. So remember the strategy here. You want to get all the x's on the side where there's more x's. Well, there's more x's on the left-hand side. We've got 3x, which is bigger than 2x. So we want to get rid of that 2x. So we're going to subtract 2x from both sides. So on the left, we're going to get 3x minus 2x is just x, and we've still got that plus 23. And the right-hand side, when we subtract the 2x, that gets rid of the 2x, it cancels it, and we're just left with the plus 12. So we've got x plus 23 equals 12. Now we just want to get the x on its own. So we're going to get rid of that 23 on the left. So we're going to subtract 23 to get rid of it. On the left-hand side, that gets rid of the 23, it cancels it out, and 12 minus 23 is minus 11, isn't it? So that is the final answer. It's the solution to this original equation here.